Hello viewers, welcome to the massive open online course on engineering mechanics. Today we will discuss about the idealization, laws of mechanics, modeling and problem solving. This covers the unit 2 of module 1. Now already we have in the earlier unit we have discussed about that engineering mechanics is used for modeling and analysis of engineering systems or physical systems. So, any physical system, when we want to make the system model, we require some theoretical assumption and some basic concepts are required. So, this is called idealization, and once we make the system model, if we want to convert it into mathematical model and solve it, we use the laws of mechanics to get the solution. So, today we will cover the purpose of idealization in mechanics, then we will discuss about the terms on continuum, rigid body, center of mass, particle and point force. Next we will explain about the laws of mechanics, and then what is the basic approach in modeling for analysis, that we will discuss, and finally we will discuss about the general steps for solving problems in engineering mechanics. Now the first question is, what is idealization? Actually any physical actions, when in our practical field day to day life, all these physical actions we want to represent in form of equations that relates the basic and secondary dimensions. So, we represent these systems in mathematical equations, and we develop these equations from basic laws of physics. So, these equations should be simple enough so that we can solve by mathematical computation. Now, to achieve this thing, we have to replace the physical action and participating bodies with hypothetical highly simplified substitutes. But this idealization has some characteristics. What are those characteristics? When we are doing this substitution, they must be such that the results obtained from such models or idealization will correlate with the reality. That means, it should be realistic whenever we make these substitutions. So, in all analytical and physical sciences, we actually apply this technique, and when we make these computations or modeling and computations, these are not very simple. So, it requires considerable amount of imagination, ingenuity and insight into the physical behavior. So, most fundamental idealization which are used in mechanics are continuum, rigid body, center of mass, particle, point force. What is this continuum? Actually this is in many engineering problems, what happened, we want to simplify the matters. If we want to simplify these matters into these molecules, atoms, then this modeling becomes very difficult and it is very difficult to handle. So, what we do, we are normally interested in average measurable manifestation of properties such as pressure, density and temperatures, which are actually dependent on these elementary bodies. But so these are actually gross effects of the actions of the many molecules and atom, and they can be conveniently assumed to arise from a hypothetical continuous distribution of matter, which we shall call the continuum. That means, here instead of these teeny particles, we assume the matter as a continuous material. Now, in this continuum, actually we are interested in the macroscopic physical model, and this validity also depend on the problem and the scale of the physical phenomena. So, a material may be assumed to be continuum when distance between the physical particles is very small compared to the dimension of the problem, then only we can go for that. And this validity of the continuum assumption needs to be verified. That means, once we assume, we have to verify it whether it is applicable or not, and this can be done only by experimental testing and measurement. So, the real matter under similar consideration and under similar loading conditions, we have to do this experimentation. Next, this idea is the rigid body. So, this is very important idea. This rigid body is a continuum that undergoes theoretically no deformation under action of forces, whatever it may be, even it is under if the forces are very large. But actually every body actually deforms to certain extent due to these forces. It may be very small. Now, in our application, when these things are very small, we can neglect the deformation and we consider the body as rigid, and so we can go for simplified computations. So, how to decide how much simplification we will do? So, the guiding principle is that we will do simplification, it should be consistent with the accuracy of the results. If the results are not accurate, we have to go for better modeling. Now, here is one example. Suppose a load is applied on a beam and we are interested to know how much force is transmitted or to the support or earth. So, if P is small enough, then the beam will undergo very little deflection and a simple analysis may be done, because we can assume that the beam has no deformation. So, with undeformed geometry we can do the analysis. But for accurate analysis, suppose according to the application, if we want more accurate analysis, then in this case what happens, then beam will have some deflection. The main problem will be here that where this force will be, that means in undeformed case we can exactly detect, we can decide the point of application, but when there is deformation, where is the point of application, that is very difficult to determine. So, this can be shown by this next diagram. Here in the undeformed condition, P is the load applied and this P dash, after deformation it is P dash, but it is very difficult to find out the point of application of P dash. So, although the rigid body analysis, this we assume that there is very less deformation. So, with undeformed model we can do, but when this is not sufficient, so we have to go for more sophisticated modeling and calculation, and these are actually very difficult calculation. So, in these cases we have to find out more realistic model which can give us the required accuracy. Next concept is the particle. What is a particle? It is defined as an object that has no size but has mass. So, it is very useful concept used in the mechanics, and in describing the effects of forces on a body, if the physical dimensions are not of importance and are not affecting the response against the applied force, then we can assume the body as geometric point. So, for analyzing such bodies, we represent them by points where the mass of the whole body is actually concentrated. So, we call them as mass particles or point masses. Here one example, suppose if when we are computing about the trajectory of planets, then the size is of no importance. So, the mass of the planet is sufficient for our calculation. So, here we can assume as the planets as masses. So, this is a planets as particles. So, here the particle assumption is okay. But another case, if you think of ice skater, so when he is spinning on the ice, what happens? The mode of rotating and those dynamics, normal dynamics is difficult to model with this particle. But if you assume that in what trajectory he is moving, in that case this particle assumption is sufficient, but otherwise it is not. Mass center, it is also a hypothetical point at which one concentrate the mass of the body for certain dynamical calculations. And actually in this previous examples on the planet and the human cannonball on skates, that means when the ice skater is moving, the suppose if it assume that he is fired from a cannon, is a cannonball, it moves like a cannonball, then in those cases we can consider the mass center for whose motion is sufficient for desired information. Now, thus when the motion of the mass center of a body actually suffices for importance desired, we can replace the body by a particle, namely the mass center. A finite force, now what is the point force? Another concept new is finite force, point force. Point force is actually finite force exerted on a body. Suppose two bodies are in contact, then they will have a interaction. So, one body will apply the force on the another body, and we know for any when any force is exerted on another body, then there will be some deformation. So, there will be some finite area through which the force is transmitted. But if we assume the body as rigid body, then there will be no deformation. So, here we assume that the whole force is transmitted through a point. So, this is a assumption. So, this is one of the concept of that is point force. It is very useful in mechanics. So, since we have formulated the concept of rigid body, imagine the, so here we have already we have told that the infinitesimal area or point. So, this simplification of force distribution, that means as the area is infinitesimally small, so there is no actually distribution. So, in this case is called point force, the force in this case is called point force. Now, another important thing is the laws of mechanics. So, this entire structure of mechanics rests on relatively few basic laws. What are those laws? Newton's first and second laws of motion, Newton's third law, the gravitational law of attraction, the parallelogram law, and the principle of transmissibility of forces. So, let us go to these laws one by one. What is the Newton's laws? Sir Isaac Newton formulated some laws. So, what are these laws? First law is a particle originally at rest or moving in a straight line at a constant velocity will continue to remain in this state provided the particle is not subjected to an unbalanced force. So, if no force is applied, the a body at rest will remain at rest, or if it is a uniform velocity, then it will move in a straight line with uniform velocity. Next law is second law, a particle acted upon by an unbalanced force F receives an acceleration A in the direction of force. So, it has an acceleration, this is proportional to the magnitude of the force in the direction of the force. So, the acceleration is directly proportional to the force and inversely proportional to the mass m. So, this law can be formulated as F equals to m A, where F is the force applied, m is the mass of the body or particle, and A is the acceleration. Newton's third law, for every force acting on a particle, the particle exerts an equal and opposite and this will be collinear and reactive force. So, one example we can give, if we consider the tug of war between two people. So, one person A, another person B on the left side, the person A is trying to pull on the towards the left side and person B is trying to pull on the right side. So, when they are equal, if there is stalemate, suppose due to the pulling nobody moves, they stay in the same position. In that case, from intuition we can tell that both are pulling in the same with the same force F. But another situation you see that when suppose the person B is slipping, then person A will move leftward by pulling the person B, then what will be the force? So, Newton's third law says that in this case also the force will may be different as F1 from the earlier force F, but both will pull in the same force, that is F1 at a particular instant. Next law is the law of gravitation. Newton expressed the mutual gravitational attraction between the particles by this equation, that is F equals to g into mm by r square, where F is the magnitude of the force of attraction, m and m of the masses, that is the two particles which we are considering for attraction, and g is the universal constant of gravitation, and r is the distance between the centers of the particles. So, the mutual forces F determined from this equation might satisfy all the conditions of third law. That means, this force of attraction will be collinear, they will be equal in magnitude, but opposite in direction. Next law is the next concept is gravitational attraction. So, here the force of attraction between earth and any body near the surface is called the weight, the W. So, this force causes the acceleration of any falling body. So, this gravitational attraction is this acceleration due to gravity is denoted by g, and it can be determined by experiments with freely falling body in vacuum, and the average value in SI units will be 9.81 meter per second square. It varies slightly depending on the location on the surface, because we know that Earth's surface is not totally perfectly sphere. So, it varies, the distance from the center varies. So, this value also varies. So, this from equation 1, that is F equals to ma. So, that if we use in this case, so W we can find out as W equals to mg. Next important law is the parallelogram law. Here actually on a particle, if two forces are applied, we want to find out what will be the equivalent force, the resultant force. So, two forces, this law states that two forces P and Q acting on a particle A may be replaced by a single force R, which has the same effect on the particle. This force is called the resultant force, resultant of the forces P and Q, and may be obtained by constructing a parallelogram. That is, if we make a parallelogram where the two sides are P and Q, then the diagonal will be the resultant. That can be shown by a diagram, that is P and Q are the two forces. So, if we complete with these two sides, if we complete the parallelogram, then the diagonal of this parallelogram is the resultant force R equals to P plus Q. Next, and this parallelogram law actually was first demonstrated experimentally by Stevenius. So, this law. Next is the that we want to discuss here is the transmissibility of forces. This law states that the conditions of equilibrium or of motion of a rigid body will remain unchanged if a force acting at a given point on the rigid body is replaced by a force of the same magnitude and same direction, but acting at different point, provided the forces have the same line of action. This can be explained by an example. Here this is a wheel and this spindle is there. So, one case is from the bottom a force V is applied and it is transmitted to the wheel. So, in place of V, if we apply the V dashed on the spindle, the overall effect on the system will be the same. So, this is the transmissibility of forces. Another example is this, in the for the wheel there is a supporting platen. So, on the left hand side there is F. So, instead of giving this force, if on the right hand side this is actually with a, if we replace this with a F dash, force F dash of the same amount and same direction, then effect will be same. So, this is the principle of transmissibility of forces. Now, the question is, when we study what is the effective way, how to what is the way of studying engineering mechanics. Actually, in engineering mechanics there are lot of general principles and concepts, and just simple theory will of little use if we cannot apply it. So, the effective way of studying engineering mechanics is to solve problems. Next concept is, once idealization we have done, we know the laws of mechanics. Next is modeling, because whenever we have already discussed that when we get a physical system we have to make a model. How to this make the model? So, modeling for analysis means that a real system of bodies, no matter how complex, is assumed to have only a few parts. These are of simple shape and that only a few major forces are acting on them. It is not possible to include everything that has an effect on the system. So, in modeling, from this statement we want to tell that you have to simplify the system and you have to reduce the number of forces, because there will be actually in real system there will be lot of forces, lot of effects will be there, but when you go for modeling you have to simplify this thing. Example, gravitational effects of other planets at the surface of earth are real, but negligible in comparison with the effect of the earth. This is one example, that is any body on the face on the earth surface. So, maximum effect is of the earth gravitational attraction, but other planet attraction will be there, that is real, but their effect is negligible. So, we can, when we go for modeling we can neglect these things. So, it is always best. So, how to do the modeling? We first will start with simplest possible model that represents the system under consideration. So, we will start with the simplest possible model, and sometimes this may involve difficult choices regarding inclusion of some items. So, we may face this problem that there are a lot of items are there which we want to include, and in that way the system will be, this model will be very complicated. So, the idea is you first start with very simple model, and if it does not satisfy your purpose, then you gradually improve it and you include the other items or effects. So, this is the way of modeling. Next, here we gives one example. Suppose this is a skyscraper building, this is a high rise building. So, this we can model as a mass, and this beam is like a actually works as a spring, and this it has a motion, wind force is applied on this actually, and this we can so this mass will have motion. So, we can dynamic analysis of this building we can do with this model. So, this is a very simplified model. Another model is for case of automobile. So, here the suspension system, here the mass of wheel and assembly is there, and over that the suspension system is there, which are connected by spring and shock absorber. So, with this spring mass damper system we can represent a automobile. So, this is very simple model. For more accurate analysis we can include more details and we can get better result. Now, the question is how to do the modeling. In making analytical models, the important assumptions must be explicitly stated. That means, when we are doing the modeling we go for simplification. So, we assume lot of things for simplification. Those things should be noted, because when any particular model is not satisfactory, we have to improve it. So, that if all these things are written, we can easily reevaluate and change those for improvement. And work in modeling complex system is, it is a very challenging when we try to model any complex system, because here it requires judgments and evaluations that those are necessary. Now, lastly, this when we solve any problem in engineering mechanics, one should be very systematic. So, here some steps are given. First, you read the problem carefully, and whatever data is given and what is required to find out, those things should be mentioned. So, it is often helpful to, sometimes the problem the way it is given, it can be restated, which actually helps us in understanding the problem. Next is draw and label any necessary diagrams to help the visualize the problem, or the, because in many engineering systems we always draw some diagrams to represent the system, which help us in understanding and modeling. And list all the relevant principles generally in mathematical form, laws of mechanics and others, many principles are there. So, which will be relevant, that we list down. Then we think of the problem, actual physical situation, and then we decide which mathematical equation will be applicable, those things we should write. Then solve the necessary equations algebraically. Actually, first, if simple models can be made and closed form solution can be found out, these actually help us in actually visualizing the things. Once it is done, or if it is not possible, then we go for computation, which are done numerically. Next step is check through the problem, making sure that the equations are used dimensionally homogeneous, all these equations, and proper units of the numerical data are taken properly, these things should be checked. Then study the answer with technical judgment. Once you get the answer, you check whether answer is proper or not, you can check in a different way. Once the solution has been completed, review the problem, try to think if there is any other way of finding the solution. So, in this session we have discussed about some important points. So, what are these important concepts? One is idealization, certain simplifications and assumptions regarding various concepts in mechanics is required, these are called idealization. Another important concept is continuum, that means it is the body can be continually subdivided into infinitesimal element with properties being those of the bulk material. The property does not change, whatever bulk material is there, even for smaller unit also same. So, this is one, it is a part of this idealization. Then rigid body, the collection of infinite number of many mass particles such that the distance between any such particles remain constant even under the action of forces. Next concept is center of mass. To study problems concerning the motion of matter under the influence of forces, it is necessary to locate a point called the mass center. Next is the particle. To describe the effect of forces acting on a body, it is observed that its physical dimensions are not of importance and really not affecting the response against the applied force, then the body can be assumed a geometric point called mass particle or point mass. And point force, it is the concept of rigid body. In the concept of rigid body, a finite force transmitted through an infinitesimal area or point is called point force. And we have discussed about the laws of mechanics. Newton's first law of motion, it is if the resultant force acting on a particle is 0, the particle will remain at rest if originally at rest, or will move with constant speed in straight line if originally in motion. Newton's second law of motion is the resultant force acting on a particle is not 0, the particle will have an acceleration proportional to the magnitude of the resultant and the direction of the resultant force. Newton's third law says that forces of action and reaction between bodies in contact have same magnitude, same line of action and opposite sense. Law of gravitation is two particles will be attracted toward each other along their connecting line with a force whose magnitude is directly proportional to the product of the masses and inversely proportional to the distance squared between the particles. Then we have discussed the parallelogram law. It states that forces could be combined by representing them by arrows to some suitable scale and then forming a parallelogram in which the diagonal represents the sum of the two forces. And the law of transmissibility of forces, a force acting at a location on a rigid body can be shifted undiminished anywhere along a line passing through that location and collinear with the line of action of the force, provided the direction of the force is kept unaltered. And we have discussed about the modeling for analysis. A real system is assumed to have only few parts, that these are of simple shape and only a few major forces are acting on them instead of including everything. So, this is the modeling for analysis, and we have discussed about problem solving. So, few important points on problem solving is the statement of the problem should be clear, precise, and a neat drawing showing all quantities should be included. Draw separate diagrams, that is here in engineering mechanics free body diagrams for all bodies involved and indicate the forces for each body. And this problem use fundamental principles of mechanics to write the equations expressing the conditions of rest and motion of the bodies and relate each equation to the figure. After answer is obtained, check it carefully. Errors in computation will usually be found by substituting numerical values obtained into another equation which has not yet been used and verifying that equation is satisfied. So, in this unit we have covered idealization, laws of mechanics, modeling for analysis and problem solving. Thank you.